Okay, as I was saying, when a VPN is installed onto a computer's internet connection, data sent from the computer is redirected to the VPN server by replacing the incoming IP address with its own IP address. When the request reaches a destination server, the destination returns the requested data to the VPN server. It is then redirected back to the computer. In that process, the VPN uses its own firewalling systems to protect clients, unlike as if they were part of an external firewall system. Otherwise, servers are isocentric in protecting user data. When a firewall is installed onto a host computer, it must be responsible for all incoming network traffic. For this reason, the mobile firewall service was invented to specify the importance of different types of security measures employed by different firewalls. Typically, any concerned user would want maximum functionality out of their firewalls. However, in having more capabilities than primitive firewalls, new ones gave the user preferences over which functions to run and which files to manage. While an office network is not the corporate mainframe may only need functionality for printers, faxes, and voice messaging within a corporation. An individual network may require high security for public access connections through the open internet. While a mobile network or Wi-Fi connection may be open to signals from other Wi-Fi connections, a home Ethernet line connects to your computer directly through the internet through a router. While the computer may come with a default firewall, a router may not be connected to another firewall. In that case, disconnecting your Ethernet or disabling your Wi-Fi when not in use is another safety measure for defending your interface. Next-gen firewalls. Now that there are firewalls for physical link, network, transport, and application layers, the next generation of firewalls will of course feature controls and protections for the session and application layers as well. These fourth type of firewall will be able to patrol the internet in its entirety and perform inspections on all encapsulations of traffic. It will be able to instantaneously delete or rewrite encapsulations, reassign packets to new destinations in real time with advanced heuristic scanning available today. It will employ computer learning networks to update itself against any new encounterable programs in real time. What are the implications of this new type of firewall? Let us refer back and put ourselves in the place of the packets. As we know, people need vehicles to travel on roads, or vehicles and their permits and their features are encapsulations, without which we could never reach our destinations. Given that, a firewall that can perform inspections on the roads themselves would not require encapsulations for every single packet, just as the roads have buses, trucks, and trains. Given that, it would already be aware of every single VPN in place, and this information would be easily readable if not properly encrypted. So, instead of designing cars that go on roads better, they thought of designing roads where cars can drive better on them. And you would have cars in one lane, buses in one lane, and etc. Let us take this notion to an even deeper level and notice that we require bodies to occupy the physical world. Okay, this is an analogy. The next-gen firewall would imply a multi-packet encapsulation that would write its own computer programs and transit through a network. Such a firewall could allow multiple programs to trade files through the networks at speeds millions of times our processing speed. Given that, we notice that our ability to build electronics is actually our ability to visit the electronic world and to notice that real-life conversations and events occur millions of times faster than we can comprehend. Taking this notion to an even deeper level still, we ask ourselves, what is the encapsulation ability of our own immune systems? When an unrecognized packet becomes deleted, its electronic force is dissipated through the circuit. Not so with bacteria. Our immune systems will encapsulate bacteria that it cannot digest, dumping its waste into our intestines. The waste is produced back out into nature. This is because bacteria is not made out of electronic force. It dissipates into atoms and molecules that form other compounds according to their own laws. Chemical laws. Unable to restructure any of the data or even record these events in progress, our bodies eject this raw data as harmful waste. This type of firewall is a Type 1 stateless packet filter. It has no knowledge or techniques for the reconstruction or redirection of bacteria entering the system. Many of them go unnoticed until they die. Seeing this example, one notices that modern firewall technology is an important application for all the different technologies in life. including biology. Not only this, but modern firewalls imply that it can restructure itself, packets, encapsulations, and routes to form other forms of useful data that won't conflict with already implemented systems. So imagine a highway where the road has a spine and can flex to other channels to redirect traffic. Weird, huh? A properly functioning packet filter must be able to restructure itself and any or all of its packet inspection agents, and where there are more than one fully capable packet filters running, each of them must be able to run full packet inspections on each other, either in real time or without slowing them down. This is full insurance against any slowdowns. And these are my links. So pause the video, copy them. Many of them have internet sources. Look up these links and read through parts of the links. Okay, so this is the text paper. I was also supposed to write a PowerPoint presentation for this. And this is the OSI model. This is okay, well, it doesn't have pictures of the different parts of the OSI model, but the physical structure is literally the computer. This is actually wrong, actually. The data link layer is where the computers connect to other computers. The network layer, that's where the information is sent from one computer to different computers through the server. Through each computer. The transport layer connects through servers. The session layers connect through ports. The presentation layer is where the server modifies and encapsulates each component packet for the SYNAC process, which I have not covered yet. And the end user layer program opens what it sends, or what creates is what is to be sent. I think the end user layer is actually where the programs are written by people. Because that's the first step, and then the last step is actually getting it through. It's like when you write a letter, you have to determine not only how it should be written, but how it should be sent, including its encapsulation, the envelope, so that other people can read it. And although the letter and the envelope are both paper, they serve two very different functions. I include, so this way it is the same as the paper, except I included pictures. So in this picture, bacteria are inside a stream of binary digits. And it explains the same thing it does in the paper. The different types of viruses: bloatware, fragmenters, switches, spyware, certifiers, rootkits. Can you? I'm going to try to let you guess which country this is. But anyway, this is what happens when firewalls fail. Too many misencapsulated streams of data, causing problems. In the firewall in its infancy. The stateless and stateful packet filter. The 3G packet filter. Now, notice. Now, one funny thing I notice is that we don't have more of these. We usually go on with these roads. And to notice, the trees serves a sort of encapsulation, right? And so do the hulls of the cars, are another type of encapsulation. And this is a patrol system. So our antivirus programs are actually not up to date with internet antivirus.